All right, y'all, today we are going to learn two more rules. We're going to learn the product rule and the quotient rule. These are derivative rules. So first, the product rule. So in your notes, please make sure you write this rule down, the product rule. And when taking the derivative of the product of two functions, so we're going to say of two functions multiplying, and then we will say the derivative with respect to x will be, and we're gonna like write how I'm gonna say it. The derivative will be, okay, and we're gonna actually write it out so that you can like practice saying it the same way. The derivative will be, and then I'm gonna put this in parentheses. We're gonna say the derivative of the first and then the derivative of the first times the second, the derivative of the first times the second, plus, oops, that's supposed to say plus, the derivative of the second times the first. So this is how I'm going to like say it every time we kind of practice these types of problems. And I'll read it out all the way. So when you're taking the derivative of two functions that are multiplying on one another, you're going to take the derivative by doing this. You're going to do the derivative of the first times the second plus the derivative of the second times the first. And now let me show you with this example. So go ahead and write this example down. We have h of x equals two functions being multiplied, f of x and g of x. I would like for you to label f of x as the first and then g of x as the second. So go ahead and label this one the first and label this one the second. And I'm going to highlight them. So f of x is the first, g of x is the second, and now we're going to do the product rule, where we actually take the derivative. Down here, we're going to take the derivative of h of x, which is h prime of x. Okay, the first thing we're going to do is the derivative of the first. So right now, we are doing the derivative of the first. So what is the first function? The first function is f of x. So the derivative of the first is f prime of x, right? That's the derivative of the first function. And then we do times the second. Derivative of the first times the second. So all I'm going to do here is just copy the second. What is the second? G of x. So this is the derivative of the first times the second. Cool. Our next step tells us to do plus the derivative of the second. So we're going to do plus, and then the derivative of the second function would be the derivative of g, which is g prime of x. That's the derivative of the second. And then times the first. So we just write times f of x. Okay, so we just took this derivative of two functions multiplying. H prime, the derivative of these two functions multiplying is f prime of x times g of x plus g prime of x times f of x. Or I say the derivative of the first times the second plus the derivative of the second times the first. Okay, cool. Let's go ahead and continue and use this rule to actually take some derivatives. So here we go. Example 1. Write this example down in your notebook. We are going to find the derivative of two functions multiplying on each other. So write this example down. And we have f of x equals 3x squared plus 4x plus 5, g of x equals 2x plus 1, h of x equals f of x times g of x. So the first thing I'm going to do is I'm going to write what h of x is. H of x equals f of x is this function, 3x squared plus 4x plus 5, right? So I just am taking this and plugging in, and then times g of x is 2x plus 1. Okay, so we have two functions multiplying on each other, and we are trying to find the derivative of that function that consists of the two functions multiplying. So h prime of x equals, we're going to do the derivative of the first. So this is the first. Let's do derivative of that. Using the power rule, we have 6x and then plus 4. That's the derivative of the first. Times the second. So times, you're just going to copy the second function. Copy this second function. So again, this is the second. So we're going to copy 2x plus 1. Make sure you put these in parentheses, otherwise your answer is not going to look right. So derivative of the first times the second plus derivative of the second. Derivative of the second function is just 2, because that derivative of the constant goes away, times the first. That's the derivative of the second. And then times the first, that just means copy the first. 3x squared plus 4x plus 5. Okay, we're going to pretend that this was a short answer question, and we are going to leave our answer in this form. So this is our derivative. H prime of x can be written like this. You do not need to distribute and simplify any further. You can leave it like that. All right, let's move on to another rule, the quotient rule. So go ahead and write down the quotient rule. And we're going to write a definition and then also write down like the way that we say it again. So just be prepared for that. Okay, the quotient rule. When taking the derivative, of a quotient, when taking the derivative of a quotient, that just means like two functions being divided. Two functions being divided. The derivative will be, okay, and this one's going to get weird. So, are you ready? This is how we say it. This is going to be really, really strange sounding at first. We are going to say low d high minus, and I'll explain this in a second. So low d high minus high d low over low low. All right. This is how we're going to take derivatives of two functions being divided of quotients. We are going to say low d high minus high d low over low low. Let me show you what that means. So as you can see down here, we have high and low labeled. I'm going to go ahead and highlight the high and the low. And then you need to know that D right here stands for derivative of. So the little d right here stands for derivative of. And then let's actually take this. Let's write h prime of x for this h of x, f over g. Okay, so h of x equals f of x over g of x. The derivative is going to be low d high. So low means copy low. The low function is g. So we're going to copy g of x, low. D high means the derivative of the high function. So we're going to take the derivative of the high function, derivative of f. So low d high, f prime of x, derivative of high. And then we have minus high. So let's go ahead and do that part. Minus, the high function is f of x. And then the next thing we have is d low, so derivative of low. So we're going to write derivative of the low function, which is g prime of x. And then over, let's see, over, sorry y'all, I'm trying to use a different color. Over means divide. Low can also be written as low times low. So let's just break this down. Low times low, which would be low squared, but we say low. So over low, that part means put that all over, divide, low squared. So the low function, again, was g of x, so we're going to say g of x squared. Okay, so if we say it again, it says low d high minus high d low over low. We have low, and then derivative of high minus high, derivative of low over low. Cool. We're going to do an example, and then we will get some practice in. Okay, so here we go. Here's y. We're trying to find the derivative of y with respect to x. So let's go ahead and write dy dx equals. All right, we start with low. So our low function, let me label these. This is low, this is high. Our low function is x squared plus 5x. So if we say low, sorry, I need some room. Okay, low is x squared plus 5x. Then we do d high, derivative of high. So we need to take the derivative of this upper function, the high function. So that's 4x cubed plus 6x squared. That's the derivative of high. So far we have low, d high. Now we need minus high. Just copy the high function, x to the 4th plus 2x cubed plus 2. Copy the high, and then d low. So now we need the derivative of the low function. So we have 2x plus 5. That's the derivative of my lower function. All over low, which is the same as low squared. Low squared. All right, and I'm going to write it. So we have low, that's this one. The derivative of high, that's this one, minus, then we have high, the derivative of low over low, which is the same as low squared. Okay, so anytime you have quotients, that's how you take the derivative of those quotients. Make sure you get this in your notes, and now let's do some practice.